to carry out what you call residual analysis. And by this, when we talk of a residual, it is simply referring to the estimate of the error term. When you have the general regression model, it includes epsilon, which is the error term. The value of epsilon is not known. The values are not known. So after we have estimated the regression model, we often use the estimated model to estimate the error term. So an estimate of the error term is known as a residual, and it is obtained by finding the difference between the actual y value and the corresponding predicted y value. So you subtract y cap from y, and that will give you the residual. So for every value of x, you can calculate the corresponding residual. Remember that you have to substitute the value of x into the estimated regression equation to find the corresponding predicted value of y. So once you have the predicted value of y, you
Well, your
subtract
video
it.
is off.
Check your network. Everything is intact. So once you have the predicted value of y, you subtract it from the actual value, the observed value, and the difference is what gives us the residual. So when we want to examine whether the regression equation is going to fit the data well or approximately be a good representation of the data, we need to have the residuals. So in order to measure the fitness of the model, one method we have to do or procedure that we apply is the residual analysis. And this residual analysis is done through what you call residual plots. The residual plot is just a graph of the residuals. So we plot the residuals versus the values of the predictor variable. That's the x values. When we have this graph, the graph is known as the residual plot. And we can use the residual plot to determine whether the regression equation that we have estimated will fit the data well or not. So if we have the residual plot, in order to get this information in terms of whether the regression model is a good fit or not, we often have to look at the pattern of the residual plot. If after you have constructed the residual plot, you observe that the points that have been plotted, they are random. In other words, the points appear haphazard. So in that case, they are just anyhow. There is no pattern. If there is no pattern, we say the residual points are random. And for that matter, the regression equation is a good fit. However, if you have the residual plot and you observe that the points follow a specific shape, for example, you may have a U shape. If you have a shape or a curve, it tells you that the linear regression model is not a good fit. But it is suggesting to you that if you use a nonlinear model, it will be better, it will provide a good fit for the data. Apart from having a U shape or a curve, any other specific pattern also suggests to us that the linear regression model is not providing a good fit. So this is how we can use the residual plot to understand or assess the quality of the regression equation, whether it is providing good approximations to the y values or not. Okay. So if you have any question, you can raise them. I'll provide answers before we look at the example. Is there any question up to this point?
So please, can you give a recap of the residual this thing?
Are you just joining? Because just recap, I'm saying that the residual is simply an estimate of the error term. And to find the residual, remember in the regression model, we represented the error time by epsilon. Epsilon is the error term, but these error terms, their values are not known. So we try to estimate them after we have estimated the regression model. So when you estimate the regression model, you are able to obtain the predicted values, which are the y caps. The y caps are the predicted values of y. And when you have them, you can use them to find the estimates of the error terms. So if you want to find the estimate of the error term, you subtract y cap from the value of y, and that will give you an estimate of the error term. So the estimate of the error term is what you call a residual. So we are saying that if you have the residuals for the y values, you can use the residuals, you can do residual analysis to in order to determine whether the regression model that you have estimated provides a good fit or not. The the observations we have to note is that if you have the residual plot and the points appear random, in other words, they are haphazard, there is no pattern. It tells you that the regression equation is providing a good fit. But if you observe from the residual plot that the points form a curve or a U shape, it is telling you that the linear model is not a good fit, but at the same time suggesting to you that the nonlinear model may be okay for the data. So nonlinear, we may have a quadratic regression model or a cubic regression model. In general, polynomial regression model. So that is if you have a U shape. That is what it is suggesting. But any other specific pattern suggests tells you that the regression model is not providing a good fit. So that is the point we are putting across. So we will now, yes,
Please, the screen.
ah, the screen, as in, are you not seeing the screen?
Yes,
I can't also see. I thought it was on my
yeah,
side,
the
but
The
screen is
screen,
not showing.
it's
the
not
screen
showing.
is being shared. Maybe you guys have problem with your network.
It's not
Who can
showing.
confirm? Who can
It's
confirm?
showing,
It is
please.
showing.
It's
It's showing.
showing.
It's showing. It's showing clearly. So you go out and log in again.
Okay, so let's look at the example, which will help us to illustrate how we conduct the residual analysis. In this particular example, this is the preamble. Agricultural science students are growing a plant. They recorded the height of the plant each day for 10 days. The plant's height in centimeters over that time is presented in the following table. The estimated regression equation is given to be y cap equals 1.87 plus 1.73x. So the data is what is given. So we have day 1 to day 10. Then they have the corresponding plant height in centimeters. What are we trying to do with this particular data? We want to create a scatter plot for the data. Then secondly, we draw a line of best fits for the data. And thirdly, we find the residual for each data point. So these are the tasks we need to perform in this particular example.
Please, is the screen showing?
Say
The
Yes.
screen
Is
is
the,
not showing.
half
the
of
screen
the
is not
task
showing. No.
can
Not
uh,
showing.
the room and half cannot. I don't know.
No showing, showing. It's not showing. Let's tell log out and come.
That network is strong. It's
I've
not
logged
showing.
out and come. I still not showing. I've logged out.
I try it
Yes,
several
it's not
times, but
showing.
it's not showing.
Same here, same here.
There are others who confirm that the
At my
screen
end.
is showing.
It's showing
So
at my end. So I don't know. It is showing at my end here clearly, but I don't know what's happening. It is showing here.
Majority are saying it's not showing. If it's showing at the end, lucky for you. But majority are saying it's not showing. So
but it's important for him to state the fact that it is showing. So that's why he's saying so. So you check from your end. Anyway, I will stop sharing and reshare it again if it will help. So as it is, I have stopped sharing. Let me share the screen again. So
Yes, now showing.
okay,
It's not showing, sir.
okay. So this is a problem we have. Let's go through the solution. So as far as the problem is concerned, we are told to construct a scatter diagram for the data, and that is what we are currently showing. The data is made up of two variables. We have height and day. Height is a dependent variable and day is independent. So this is the scatter diagram for the data. Okay, so you can see that the points are in a straight line. Okay, in the second part of the problem, we are supposed to find or draw the line of best fit. Remember that the question provided us with an estimate of the regression equation. We want to draw the line of best fit as we discussed yesterday. You're supposed to have from x values within the range of x. We can select two x values or three x values and determine their corresponding predicted values of y. When we have these predictions, we plot the points. We are going to superimpose it on the scatter diagram and then join them using a ruler. So that is the next task, and that is what we have shown here. So just a matter of uh, choosing any arbitrary x values, but make sure that those values that you are choosing are within the range of x values. When we choose those x values, we find their corresponding y values. Then we plot those points in the scatter diagram, after which we use a ruler to connect them in a straight line. So this is the line of best fits that we have drawn. Remember that the scatter diagram doesn't have any line. It is just a plotted point. So if you now draw the line using the estimated regression equation, it gives you the line of best fits. So that's our second uh, task. In the next task, we are supposed to obtain the residuals for each value of y. So we find the residual for each data point. Remember, okay, so let's look at how this is done. So the data came to us in the form of height and day. Those are the original values. Given the estimated equation, we can find the predicted values of y, and that is the column with the heading y cap. So these are the predicted y values. If you want to find these values, use the estimated equation. It is given in the problem. If you want to find the first y cap, you substitute 3 into the equation. Sorry, you substitute 1, that's the value of x. Substitute 1 into the equation and evaluate. It will give you 3.6, and that will be the predicted values of y. So this value corresponds to the original value 3. So we do for all other values of y to obtain the predicted values. Once we have the predicted values, we find the difference between y and y cap, and that will give us the residual. So we have used your calculators. Let's do the first two and the last value. Let's find the difference between 3 and 3.6. So you have 3 minus 3.6. It should give us negative 0.6. Then we have 5.1 minus 5.33. The residual should be negative 0.23. So this is how we calculate the residuals. Okay. So you find that the residuals are made up of positive and negative values. If the residual is negative, what it means is that your estimated or predicted y value is larger than the actual value. So you're going to have the residual be negative. The residual will be positive if the predicted y value is smaller than the actual y value. So this is how it is. Okay. So that is what we are required to do in this particular part. We have determined the residuals. In the next part, we are supposed to find or draw the residual plot for the data.
Your screen is off again. Oh.
Check your network.
That place it just went off.
Again.
Okay,
Now your screen is on.
so let me reshare it. I'll stop sharing and share it again. So I'll share it again.
Can see now.
Okay. So let's look at the next part where we are supposed to draw the residual plot for the data. So in part C, we calculated the residuals. So we are going to use them to draw the residual plot. If you are drawing the residual plot, so we're going to have the values of the residuals plotted along the vertical axis. We draw or plot the residuals along the vertical axis. Okay, so just a moment. Just a moment. Let's check. Just a moment. I want to cross-check some information. Okay. So we plot residuals on the vertical axis, and then the plot of the x values on the horizontal axis. So for every point, we're going to have pairs of values. The first is the x value. The second value of the point is the y value. Sorry, is the residual. So we have a point which is made up of x value and what? The residual. So let's look at.
So we are not on this example.
Come again.
We are not on this example.
You listen to the sound, okay? Listen to the sound. As I talk, I'm scrolling. Eh, so I'm just showing you the residuals that we have calculated. Okay, okay. I think that these are the residuals. This is the problem we are looking at. Okay, so now we have the residuals values on the vertical axis. Then we have the values of x, the predictor variable, along the horizontal axis. Now, because the residuals is made up of positive and negative values, there's a need to show the positive part and the negative part of the y-axis. So this is what we have. Okay, so that you can have both the negative and positive values plotted. So along the horizontal axis, we have the x values, day 1, day 2, up to day 10. So this is going to be the residuals plot. Now, if you have this particular residual plot, you can use it to assess whether the regression equation provides a good fit for the data or not. So
So
here,
you are being off again.
who else can confirm?
It is showing.
I can confirm.
It's true.
True.
It's showing. It's showing.
Yes,
Okay,
it's
so
showing clearly here. So I don't know what's happening.
hmm, okay, you let me off it and on it again. Is it okay?
Yes, sir. It's okay now.
Okay, so this is the residual plot. So the purpose of it is to assess whether the regression equation provides a good fit or not. And we are saying that if you have the residual plot, you observe the points, the plotted residuals. If they are random, it tells us the regression equation provides a good fit. Means that it is approximating the values of y so well. But if you observe any pattern, it means the model is not a good fit. So looking at this particular graph, what can we say? What can we say about the fit of the regression equation?
So we can say that the line of best fit is a good approximation for the data.
So instead of saying the line of best fit, just make reference to the estimated regression equation.
Okay,
It's
sir.
not okay. So the estimated regression equation provides a good fit for the data. Okay. And it is so because the residuals appear randomly. There is no pattern of the residuals. Okay. So this is the way we
Hello.
conduct. Yes.
Sir, please. So if a question like that comes, we must do double plot. We do the line of best fit before we do the residual.
This one, it depends on what the question asks you to do. This particular question was specific. The question uh, demanded that you construct the scatter diagram, after which you draw the line of best fit. If you want to draw the residual plot, you don't necessarily have to do line of best fit. The line of best fit, as it is shown here, is just another way of trying to gain an understanding of how good the model is. As you can see, majority of the points are falling on the line of best fit. The line of best fit gives you estimates of y, so that is y cap. It is y cap that is that the line is representing. But these points are the actual values of y. So if you find that the actual values are lying exactly on the line of best fit, the residual is going to be 0. If it is very close to the line, the residual is going to be small. But if the point is lying far from the line of best fit, the corresponding residual is going to be large. So if you don't have the line of best fit, you can still do the residual plot. As for the residual plot, you only need your residuals and your x values. You can even plot them without the scatter diagram. So as it is, this is a fresh plot. We have not superimposed the residuals on the line of best fit. Neither have we superimposed the residuals on the scatter diagram. It's a graph on its own. So if the question asks you to draw a residual plot, you can do it without the line of best fit. But in this particular example, we are just responding strictly to the question. I hope you are okay.
Yes, please, doctor.
Okay, so there is another example, and similar to what we have discussed. So you can have a look at it, but I'll just pay attention to one aspect of this particular example, and that is how the residual clause will appear. So in this particular example, this is the residual plot. Let's look at it. Have you seen any pattern? These are the
Yes,
plots. So what pattern have you observed?
uh,
U-shaped pattern.
So there's a U-shaped pattern. So what does it mean as far as the fitness of the model is concerned?
yeah, so it means the estimated regression equation is not a good approximation for the data.
Okay. So it is also suggesting to us that the nonlinear regression model may be okay to model the data. As you can see, you have a U shape. So perhaps if you do quadratic regression, that one may fit the data. So sometimes if the linear model is not appropriate, the pattern of the residuals may suggest to us the best regression model we can use. Okay. Is there any question? Okay.
So,
Yes.
please, what about if the pattern of the residual is linear?
If the pattern is linear, that's one still for us to remember the model itself is linear. If you do the residual plot and the residuals form a linear pattern, it tells you that the model is still not a good fit. We should expect random residual plots. We should expect random residual plots. So any other, it will not. But this is not the only use of the residual plot. Sometimes it depends on how the plot is done. Instead of plotting residuals against x values, sometimes you can plot residuals against y values, or plot residuals against the observation numbers. That is, you do a serial plot of the residuals. So those ones too are there. And for each of them, there's a particular pattern you are looking at for. Depending on the plot, sometimes if you have a linear pattern for residuals, it may tell you that your linearity assumption is what? Present, is met. Sometimes we see the straight line, it tells you that the normality is what? Valid. So those are some of the, but this particular residual plot that we are using is to check whether the linear model fits or not. And the pattern that we use is that the point should be what? Random. So a linear pattern also means the model is not a good fit. Okay, so that is how the residual analysis is done. Let us, I'm just sounding a warning. I've made the point, I'm just repeating that here we are plotting residuals against the values of X. And we expect that if the model provides a good fit, the pattern should be what? Random. There are different kinds of residual plots. So when you read textbooks, be mindful of this. Okay. We'll look at the next session, session 5. In this particular session, we are further looking at other ways of assessing the quality of the regression equation that we have estimated. So this time around, we want to look at how we can evaluate whether the predictor variable, the independent variable used in the equation, whether it is useful in predicting the values of y. In order to determine whether the x variable is useful for determining the values of y or not, we have to conduct what we call the test for significance. In other words, we are testing to see whether the predictor variable is important in predicting the values of the y variable. So that is the essence of this particular session. Now, before we look at the specific procedure for the test for significance, we want to understand what you call the standard error of estimate. Here, as I indicated, it is a further step of checking the quality of the regression equation. And here, in order to check the quality of the equation, we are looking at how close the values of y, the original values of y, how close they are to the line of best fit. If the points are close to the line of best fit, it suggests to us that the regression equation is valid, or it is providing accurate predictions. If the points are far from the line of best fit, it means that the regression equation is providing less accurate values. So you find that the plotted points, the actual values, they may not lie exactly on the line. If they lie exactly on the line, your residual is going to be 0. That means that your prediction is exactly equal to the actual value. But in an instance where the predictions are different from 0, they may be lying above the line of best fit, or the actual values are lying below the line of best fit. Okay, so in this particular regard, you find that the points, the actual values, they are deviating from the line of best fit. So we need a measure that will indicate to us how close the values are to the line of best fit. If the line of best, okay, and this particular measure that will give us this information is what we call the standard error of estimate. When we calculate for this particular value, it will indicate to us whether on the average the actual values are lying close to the line of best fit or they are lying far from the line of best fit. If the value of the standard error of estimate is small, it means that there are little deviations of the actual values from the line of best fit. But if the value of the standard error of estimate is large, what it means is that the actual values are lying far from the line of best fit. So if you want the standard error of estimate is represented by S, the letter small s. So that is the notation. So in this particular uh, presentation, anytime you come across S, it is measuring the standard error of estimate. And when we discuss the assumptions of the linear regression model, we made mention of the normal distribution, which is having a mean and a variance. So the variance of the y values, in fact, is calculated, in fact, is simply represented by the standard error of estimate. If you want to know the standard deviation for the y values, it is measured by the standard error of estimate. Okay, and this is how it is calculated. We have to find the sum of square deviations of the y values, the sum of square deviations of the predicted values from the original y values. You will find that when we discuss the principle of least squares, it was this same expression we used. So we need to find the square deviations of the y values from the predicted in order to calculate the standard error of estimate. So this is the formula we use for that particular measure. Okay. And as we have already indicated, when the predicted value is exactly equal to the actual value, the difference is going to be zero. What it means is that if you draw the line of best fit, the original y value is going to lie exactly on the line. So that's why there is no deviation. So the value is zero. Okay. But when you calculate and the value is large, it means that the line of the equation is not providing what good fit. We find the standard error of estimate to be large. And if it's giving you small value, it tells you that the equation is providing quality predictions. Okay, so the formula has been given, and that is what we have here. So if yes, do you have problem with the screen?
Yeah, it's back now.
Okay, so this is the formula we can use to calculate the standard error of estimate. There's another version of it which is given by this. So if this is not convenient to use, you can use this alternative. So these two are different expressions, but they provide you with the same value. Yes. So these are two alternative formulas we can apply. Let's look at an example how we can implement the formula. So we are making reference to example 34. We want to find the standard error of estimate for that particular regression equation. Let's go back and understand what was in example 34. So in example 34, okay, so the example 34 is where we're looking at the relationship between plant height and day. relationship between plant height and day. In this particular example, remember, through the residual analysis, we determined that the regression equation provides a good fit. That was the conclusion we reached. Now we want to measure the standard error of estimate, how close the values are to the line of best fit. So let us look at the solution. Okay. So in this
Says
particular,
but cannot see the screen again. Oh.
so as you speak, you can see it.
Yes, please.
Okay. So I'm going to off it and on it again.
Yes.
You still cannot see.
Yes.
Okay. So I've off it and I'm on it again. I'm on sharing it.
We can see.
Okay. So here we want to calculate the standard error of estimate. And in the formula, we need to find the deviation of the predicted values from the actual values. Then we find the square of it. So this will be. In any case, in that particular example 34, we had calculated the residuals. So it simply means that we need to find the sum of the squared residuals. So for every residual, you find the square of it. That's what we have in the last column. We are finding the squares of the residuals. So when we finish, we sum all the squared residuals. And when we do that, we are expected to obtain this value. It is 0.6245. Okay, so when we substitute into the formula and evaluate, we're going to have 0.279. So that is the standard error of estimate for that particular regression equation. Okay.
Sir,
No. Yes.
concerning the screen issue, I don't know if majority of us is facing the same challenge or just few of us. So if you can find out, then we see from the class.
It's the same to us.
So as we speak, is it showing or not showing?
Not
It's
showing.
not showing. It's not showing.
But
It's
it's not
showing
showing.
again, oh.
It's showing you.
Yes, it's showing. It's showing clearly.
Okay, I've off it now, so I'm going to share it again so that we can. I'm going to share it now.
And now it's showing.
Okay. So after we have done the substitution, we evaluate and we are getting 0.279 as the standard error of estimate. David, your hand is up.
Yeah, dog. Please, with the standard error estimate,
Yes.
why is it that is divided by n-2? Because I know that with the variance, it was divided by n-1, but here we are doing n-2. Is there any explanation behind it?
Which particular variance?
When you are calculating the variance for the sample size, normally is the same formula, but it's just that you divide by n-1.
These are different quantities. Okay. As indicated, the standard error is like a standard deviation of an estimate. The estimate here is a y cap. Okay. The y cap are their estimated values. If you are calculating a standard deviation in statistics, the specific term is standard error. So when you hear the term standard error, it means it is what? The standard deviation for an estimate. But if you take standard deviation itself, it tells you as a standard deviation of what? Actual values or observations. Okay. But here as -2 because you have one predictor variable in the equation. Okay. So we are subtracting the number of parameters in the equation. This way I didn't want to mention it, but you have brought it. So if I explain and you get yourself confused, it's up to you. Please
Once again,
just listen. It's not difficult. It's very simple. When you take the regression equation, you have y equal to what? Alpha plus beta x. Your parameters of the model, it is what? Alpha, beta. There are two of them. So if you want to, you are dividing, it is what? N minus the number of parameters. The parameters are 2, so you have n minus 2. Another way you can do it is this. N minus number of predictor variables minus 1. Okay, so number of predictor variables is 1, and you subtract another 1. So that gives you n minus 2. So that's the reason why we are subtracting 2 in this particular instance. Okay,
Thank you, Madam.
okay. So we have finished the discussion on the standard error of estimate. We now want to look at the standard error of beta cap. Can you see the screen?
No, please.
No,
yes,
please.
sir. Yes, sir.
So what is wrong with? Okay, so I will stop sharing and reshare again. I don't know why it is happening. My network too, I have good network. Sometimes to others are seeing and some cannot see. Okay, so I have reshared. Is it showing now?
Yes.
Yes, sir.
Okay,
It declare.
okay. So another measure we want to look at is the standard error of beta cap. Now the beta is just a parameter of what? The regression model. Sometimes we can assess the quality of it, whether it is reliable or not, by calculating the standard error of the estimate. In other words, it's the standard deviation for the beta cap. So because it's an estimate, we don't use the term standard deviation, we use standard error. Okay, so the standard error of beta cap is what we are representing by S subscript beta cap. S subscript beta cap. That's the notation for the standard error of beta cap. So we can calculate it by dividing the standard error of estimate S by this quantity. Okay, so that is how we calculate it. So the quantity that we have here, if you take the square root, I have to do some, what we have in the square root, the summation of x minus x bar square is what we call the sum of squares. Please check if the screen is showing.
No.
It just
Okay.
went.
Okay. So when I scroll and I don't see it in the screen being showed, I suspect that there's something wrong. That's why I was prompting you. So let me do it again. And this thing is going to worry us. Is it okay?
Yes.
Okay. So here we are saying that if you want to calculate the standard error of beta cap, which we are representing by S beta cap, we have to divide the standard error of estimate by this particular expression. So we are saying that the expression in the square root sign, the summation x minus x bar square, is what we call the sum of squares for s, the sum of squares for the x variable. So that's how we can calculate it. So this is the formula for calculating the standard error of beta cap. If you want to, if this is difficult for you, you can apply the second formula. It will give you the same result. With the sum of squares, it doesn't include the square root. Okay, it doesn't. It's just the expression in the square root. That is the sum of squares. Okay, so let's consider an example to illustrate the use of the formula, how we can implement it. So we again consider example 34. We want to calculate the standard error of estimate, the standard error of what? Beta cap.
Hello, Zeb.
1 hour.
Please, those of us whose screen are showing, if you scroll, it doesn't scroll.
So if it's not scrolling, it means there's a problem. So currently, are you seeing? I'm showing the table, the solution. Are you seeing it?
No, I'm seeing for ease of
Okay,
communication.
so I've seen it. So myself, where I am now, it is not shown in the shared screen. So that tells us that there's a problem. I don't know if it is something, if it has to do with the network. Press, I don't know why.
Yeah, sir, please. I would like to suggest that we will all open the slide on our maybe phones or whatever, so that you will be taking us through, so that it shouldn't be going on and off that
The,
way.
dif- the
I suggest.
difficulty with it is that if you don't know the current page I'm speaking to, it will be difficult for you to follow the discussion. Okay. By any case, you can have yours if you can open your notes somewhere. Yeah. Okay, so currently we have the table. We are making use of example 34. That's the relationship between plant height and the day. So you want to find, remember in that particular example, we are given the estimated regression equation. We want to find the standard error for the beta given. Okay, so in that regard, we want to find the squares of the x values, after which we find the total of those squares. So let's look at the substitution. So this is the total. So again, yes, share screen is not scrolling. Okay, so the total of x, we have 55. The total for summation x square, we have 385. In the previous example, we had calculated for the standard error of estimate, which is what we have here. So we substitute into the formula. So after we have done the substitution, we evaluate and we are getting 0.031. 0.031 is close to 0. That tells us that the beta that we estimated is a reliable estimate because the standard error is given as a small value. So the estimate is what? Reliable. Okay. So this is how we calculate the standard error of estimate. In fact, all the things that we are doing, the standard error of estimate and then the standard error of beta is expected to help us to carry out the test for significance. So now that we know how to calculate the standard error of estimate, and we can also calculate the standard error of beta cap, we now have what it takes to do hypothesis testing about the beta cap. Now, as I have indicated, sometimes in order to measure the quality of the regression equation, we need to assess whether the predictor variable is important in predicting the y values. In order to get this particular information, there's a need to carry out a test for significance about the coefficient of the predictor variable. So on this particular basis, the hypothesis is going to be stated as beta equal to 0. When beta is equal to 0, and in the event that you fail to reject this particular hypothesis, what it means is that there is no relationship between the predictor variable x and the response variable y. But if it is significant, if the test is significant, we reject it. If you reject the H naught, it means that the relationship between x and y is what? Significant. And it tells us that the predictor variable is useful in predicting the response variable. But if you come to look at it, you know, in the regression model, there are two parameters, alpha and beta. We often conduct tests of significance about the beta parameter because that is what is keeping the relationship between x and y. If beta is 0, x cannot stay in the equation. Okay, so it is important to rather conduct the test of significance for the beta because of this particular because of the role it is playing. It is based on the beta that we are able to have the connection between x and y. Okay, so most tests of hypothesis is about the coefficient of x and not the constant term alpha. Okay, so here the null hypothesis is going to be a statement about beta, and that is beta equal to 0. If this hypothesis is not rejected, there is no relationship between x and y. But if it is rejected, it means there is a significant relationship between x and y. So let's look at the procedure involved in conducting the test for significance. So as usual, the screen is gone off, but I'm going to bring it back so we can look at the steps involved in conducting the test for significance. So these are the steps involved. So first of all, when we are given the data, we need to find the estimated regression equation, i.e., you find the least squares estimates of what alpha and beta. After this, when we have the estimated regression equation, we also try to verify the assumptions of the linear regression model. Are the assumptions present or they are absent? This is what we also need to check. Once this are established, then we can go ahead and conduct the test for significance. In testing for the significance, we specify the hypothesis, and the null hypothesis is that beta is equal to 0. If you say beta is equal to 0, you are simply saying that there is no relationship between x and y. In other words, you can say that the variable x is not useful in predicting y. Or you can say that the coefficient of the predictor variable is not significant, or the coefficient of the predictor variable is 0. When we say something is 0, it simply means it is not significant. So instead of saying beta equal to 0, these are other ways you can state it. There is no relationship between x and y. The predictor variable x is not significant. So these are some of the ways you can state it. Now the alternative hypothesis can be one of these three. So you can have beta less than 0, beta greater than 0, or beta not equal to 0. So after which we choose a level of significance alpha, 1%, 5%, 10%, and so on. Then we calculate the standard error of beta. That is what we have done in just before, uh, immediate past discussion. Okay. So once you compute the standard error of estimate, I have to reshare. In fact, this time, anytime I scroll, I have to go off. I have to off the screen and on it again. Otherwise, it doesn't reflect. Okay. So we are saying that we compute the standard error of estimate. That is very important. Once we have the standard error of estimate, we specify the test statistic. The test statistic we use in this particular test is the T statistic. And this is how it is calculated. We are supposed to have the beta cap, the value as in the estimated regression equation, minus the hypothesized beta value, divided by the standard error of the beta cap. So this is the formula we use. And the distribution is what? T with degrees of freedom n minus 2. Now, when we finish calculating for the value of the test statistic, we find the critical value, which will help us to construct the critical region, thereby providing the decision rule. Okay, so these are the decision rules. If the test is left-sided, then this is going to be the decision rule. You reject H naught if T calculated is less than T minus from table. If the tail is right-sided, we reject H naught if T calculated is greater than T, the critical value. But if it is two-sided, we reject if any of these rejection regions is satisfied. So either this or that. So these are the decision rules. Decision rules. So once we take the decision, then we state the conclusion. We state the conclusion. So these are the steps we need to follow through in order to conduct the test for significance. So we are going to consider an example to illustrate this particular procedure. Screen.
Hello, sir. Can you hear me?
Is there any question?
Yes. Can you hear me, please?
Speak up. Your voice is far.
I'm saying that
Yes.
earlier on you said if there's no relationship between when the beta is equal to 0, then that means there's no relationship between x and y.
Yes.
Which is the response variable and then the predictor variable. Then you also said that you can state that in a different way. So what other way can we say? You say the predictor variable x is something. I wanted to jot that in the back. I couldn't get it.
Please, as for these things, you
said
can
another
take
way of
note.
stating.
Yes, I said I repeated them over and over. So I'm sure after the discussion, you can contact your colleagues. They'll say it for you. We have a lot of challenges, so this back and forth will not help us. So let's finish. If there is time, you put the question across. I'll repeat it, but I've said it several. So let's look at the solution to this particular problem. We want to, in this particular problem, we are making reference to the example 34, where we looked at the relationship between plant height and day. Remember, the regression model was sent to fit the data. We want to see whether the predictor variable X, in this case, which was the day, is useful in predicting the plant height. So this is a hypothesis we need to test, i.e. beta is equal to 0. So this versus the alternative that beta is greater than 0. Beta greater than 0 simply means that the coefficient of the predictor variable is significant. So we conduct the test at alpha equal to 5%. Now, as stated in the procedure, when we are given the problem, we need to estimate the least squares regression. We find the alpha and the beta values. More importantly, the beta value, because that is what goes into the hypothesis test. So once we are given the regression equation, we carry on with the rest of the steps. Okay, so as for this particular step requires that after you have estimated the model, you also check for its fitness, whether it fits the data or not. And that one has already been established through the residual analysis. We found the regression model to fit the data. Okay, so let's look at the rest of the steps. As far as the hypotheses are concerned, we have already indicated this in the problem. That we are testing H naught again equal to beta, where beta is equal to 0, against H1, where beta is greater than 0. So that's the hypothesis we are testing. The level of significance is 0.05. In the previous examples, we calculated the standard error of beta cap. So if you don't have that value, you have to go through the procedure to calculate it. But in this particular example, because we have already dealt with it, we have the value. In the estimated regression, we are given the value for beta cap. So we make use it in our calculation. So at this stage, all the information we need to find the value of the test statistic is given. So we simply put the test statistic. In this case, it is t equal to beta cap minus beta. But because under the H naught, the beta is 0, we decided not to show the second term in the numerator. It was going to be beta cap minus 0, which is beta cap. We divide this by the standard error of beta cap. So this is a substitution we have made. Beta cap is found to be 1.73, and then the standard error of estimate is 0.031. If we divide, we're expected to obtain 55.806. Those of you with calculators, you can check the answer. So T calculated is 55.80. So let's look at the critical value. Let's look at the critical value. We have alpha to be 0.05. Let's calculate the degrees of freedom, which is n minus 2. In this case, it's going to be 10 minus 2, which is 8. So degrees of freedom is 8. Alpha is 0.05. So the critical value, if you read from the T distribution table, we're going to have this value 1.86. 1.86. So now we formulate the decision rule. The decision rule is that reject H naught if T is greater than 1.86. If T is greater than 1.86, reject H naught. That is the decision rule. So on this basis, are we rejecting or not rejecting? Yes.
You'll be rejecting.
So we reject H naught. So what should be the conclusion?
That B is greater than 0.
Okay, so B is greater than 0. So here the implication is that there is a significant relationship between plant height and day or number of days. You can also say that the predictor variable number of days is useful in predicting plant height. You can also say this. Okay. So this is how we test for significance. Any question? Do you have questions up to this point? Do you have questions?
No, sir.
Okay. So that brings us to the end of session 6. We are now into the last session, session 6. We are into the last session, session 6. Here we are going to look at computer software programs that we can use to do regression analysis. But the way it is, we are not going to go into it because we should have done prior arrangement. This software you need to install in onto your computers so that we can look at it. But I am just going to leave it with you in some kind of assignment. It's not every time that if you have data, you should be doing manual calculation as we have been discussing. There are computer software that can help you do the analysis. If you want to do regression analysis, there are computer software programs for that. If you want to do regression analysis, you can use computer software programs to do it. There are steps you need to follow, and then you have your results. So those ones, I will leave them to you. We will not cover them in the exam, but it's very important that you know them so that it helps you to analyze your data with ease. So let me give you this. For example, if you use what you call Microsoft Excel to analyze your data, I'm just going to show you how the results will look like. So let me get it for you so that when you come across it, you'll be able to make head and tail out of it. Okay, what I'm showing you here is a regression output, not correlation. So let me check. Okay, thankfully this time it is showing. So if you run regression analysis in Microsoft Excel, this is how the results will appear. Okay, as for the procedure involved, just go through I don't know if it is now or after your exams. Go through the steps and see how the analysis is carried out. When you analyze, this is going to be your results. First of all, you are given the summary output. This is the summary output. This summary output gives you what you call multiple R. That is, if you have a regression model that contains two or more predictor variables, you have what you call multiple R. It gives you the correlation between the set of predictor variables and the response variable Y. Then you have R squared. That is the square of the correlation coefficient. It will give you this value. What you call the coefficient of determination. That is R squared. So the value is going to be given. So if you cut, this is simple regression model. So the multiple R is the same as your correlation coefficient. So if you square this value, it will give you the R square. Then we have adjusted R square. If you are dealing with multiple regression model where you have many predictors, then you adjust the R square values based on the number of predictors. That's what we have here. What we calculated in our example, the standard error of estimate, it is reported here. You can look at it. But this particular example is not using the data that the plants have. That's a different data. I'm just explaining to you aspects of the model. So here, standard error of estimate S, the value is given here. Number of observations is shown here. What is the size of the data? It is 12. That's what we have here. Then what we call ANOVA table, analysis of variance table, is what we have here. This particular table helps you to conduct tests of significance for the overall model, the entire regression model, whether it is significant or not. We haven't looked at that in this particular discussion, but this particular table gives us information to do the overall test of significance. So I'm just mentioning it. It wasn't part of our discussion. This last table contains information about the estimated regression model. It also contains information about the test for significance. Okay, so this is where you get the information. If you want to write the regression equation, if you want to write the regression equation, this is the estimate for the alpha, the constant intercept. This is where it is. This is where you pick the value. The coefficient of the predictor variable beta. This is where the value is. So if you want to write the regression equation, these are the values you have to use. They are here. Now the standard error of beta cap, the value is here. If you want to calculate the t statistic, you divide the coefficient of beta, this value, you divide by the standard error, and it will give you the t statistic here. So that's what you have. Then you have the p-value, whether to reject H0 or not, the values are here, you use them. So if you have the regression results, it will look like this, and this is how you make meaning out of them. Okay, so you can read them. There are questions for you to try at your leisure time. Okay, do you have questions up to this point? We have come to the end of our discussion of Unit 6.
Hello, Doc. Please, good afternoon. Good morning, rather. Doc, please, next week we should be writing our quiz, and I want to find out the unit that we should cover for the quiz. Is it unit 1 and 2, or we should cover up to unit 3, please?
So this year you are writing 2 quizzes. Quiz 1 will cover units 1 and 2. So quiz 1, units 1 and 2. Quiz 2 will cover units 3 and 4. Quiz 3, units, quiz 2, units 3 and 4. Is it okay?
Okay,
Yes,
Doc.
sir.
Thank you.
The end of semester will cover all.
Okay.
Please, sir, is there any tutorial question for us for the end of semester? Is there any tutorial questions for us, please?
As for that one, just solve questions. I give you textbook. So just solve questions on the areas that we have discussed. Okay. You don't know anybody to take past questions from. Your centers, if you go to the center, your coordinators, they should have past questions from last year. So if it is possible,
Okay, sir.
We don't have one.
you write your exams at given centers, isn't it? So see your coordinators, see the coordinators and tell them that you need past questions for so and so course. They should have them. Okay. Unfortunately, okay, I don't know if I can get a copy of the questions last year, but I'll search through my materials. If I get them, I'll take screenshots and send them to you. Okay. So Emmanuel or any of you, you can remind me on Monday to search for the past question. I should have a copy of it. If I get it, I will just screenshot and send them to you. Okay, say. Yes. Is there any other? I'm told you'll be writing the first quizzes from 15th of this month, November.
Yes, sir.
So once you have this, you can begin preparing yourself towards that. Okay. So we have come to the end of the discussions for the semester. At this point, I'm wishing you well in the assessments. But if from time to time you have to seek for clarifications, you can call. The numbers are there. Okay.
Thank you, Lord. I'm most grateful.
All right. Okay.
Thank you.
Yes, sir.
Elisha. Elisha didn't call me when a dog
I
came.
do.
Elisha.
Yes.
You didn't prompt me when dog came. I just joined though.
I also didn't join early.
Oh,
Dog,
but
I saw
so
what
joined.
time earlier.
They thought he thought for about 30 to 40 minutes before I joined.
Oh, means you see I'm having point and me by so many minutes about so. Wait, you might have about.
Me compare one almost say. And I am on the tour was it 10:22. And almost say oh try the other one change them there. Now they know about no more legend.
Yeah, some. Yeah, some my whole shit almost. See, I'm enjoying it.
That unit 5 from my
Oh, my really need say so.
Nobody like session 5
You, man, see, we na you know. First reading for the first quiz, second quiz 3 and 4.
If only they will go by that.
No, I for no can share now. The easy to form for on for money.
No, better thing they are saying problem.
Oh, the message tell any problem. Oh,
I thought I coordinator no. This I can't say there. I say I will cover unit 2, unit 1 and 2 pepe.
no, no, deal.
I will cover you. Who's on the train? Okay.
Auntie, you mentioned your budget, no?
if you're not trying starting it is on setting is not in so I got set up
I'm on fire. What will be our print to
that
about question be our 1 year print? Question when your question be our print.
have you
Kasuma Bwaji.
I'm sure. What's it?
Most ya de na jam.
Me Mrs. I'm going to be crowd. I'm a Benny. I must see the Jammy Benny.
Ani ni jani ba 30 minutes ni.
Oh, Mrs. 5 minutes. Yeah, 5 minutes. 5 minutes. Yeah, doctor sign off one. I mean, we can't say me be join. See, man, say.
So you have five years time.
Oh, I didn't know better you.
Me cause another lecture be back.
Lecture ben, and I said statistics ben here online. I said, I can face to face. I was saying, okay, but I Richard, I went to China, never quite now for the last assassin. So you lecture, and be a bit.
No, we need statistics.
Why? Matty. Madam Cynthia. Hello, Madam Cynthia.
Yes, Mr. Karim.
Oh, you see me, you know who that one.
Mr. Kasim.
Oh, you know who that one. Madam Cynthia, that ben you be una watch them in that you take a dog by and then and run in there.
Hey, I sent Ben out there, Ben. Oh, pardon.
Me just send me back. Man, you be enjoying you. Me join your call from Mama, Muka Soba, you don't have a friend, so my man, me and you. Well, I'll tell you if you're on buy.
That was a weird.
Yeah,
Baba no. Baba. And I Baba na. Oba no we share we Baba na uncho. Also chapter 1 and 2 and quiz 1 Baba.
Son of kind.
Aha, na quiz 2 no so.
Chapter 3
I 3 and 4. Now me exam tonight from 1 to 6 nyina.
You ana young going Baba from 1 to 6 in a bed.
Me you say ya just as we nya bi nyo. Nya bi nya.
Madam Cynthia about the MFM. Madam Cynthia dog tea.
Hey, Minyanka medwanu mu mo center ho no mo kra.
Yes, that
okay past question as na yes past question we betimi out to be.
You also a copy past question pa.
I say past question from last year.
So the other past question. Anna, regular for no more. And a regular for no more questions in Yanka bet me a boy. I'm being a man, Cababo, Pananka, interested with me and so.
I said,
last year, past question there, but I am you know, Baba.
Hey, sir.
Yeah.
Wow.
And when you have a good common platform, no, so say,
platforms
me so be a send me the big so. And about was heavy. Unya ea, what do coffee, be an your coffee fee until one of them. When you just better, I'm going to tell me Naka 111, me and pass and Imperial.
Good answer.
Bro.
Now, you know about now.
Hey, Macau, Mama. Debbie. Some of them walk to me, Indiana. What I need, yeah, and I was here for that.
When you can rough.
Tia mompai, be a fine.
Now, the only who show.
The Aquama can't say as you day. Baba na nua we usua na ntia sia no baba. Unya question bi ya, the answer will fail.
Odi, who the one kind of friend. Odi, and who are you? If you are answer.
Brass, Okapom say, Okapati, you got you say, Masona, also by social, so on also by a mass.
That comes from the formless or Horma, who go to me, you see the eye. Now, only Horma style.
Yamunampai.
I did hear you when there.
Hey, Kwesipa.